Alright, so in this video, we're going to talk about multiple covalent bonds. And now sometimes there are many instances where you have atoms, or we have atoms within a molecule that they could actually make more than one bond. Okay, like let's jump into example so that you can see exactly where I'm coming from. So let's just say if we have two oxygen atoms and one carbon atom, okay? And if you were to note down their valence electrons, so carbon has 4 valence electrons, we know oxygen has 6 valence electrons. All right, and so they're gonna share. All right, and typically they share a set. And so if you combine them accordingly with the structure, so then you'll see it looks like this. Okay, and then we highlight the shared electrons, so that way we could kind of see what's really going on here. All right, now this structure right here is a very unstable structure. This will not happen. All right, why? Okay, let me draw also the line way, so that way you can kind of see where I'm coming from here. So that way all right, so first of all, if you recall from the last video, we know that carbon must have 4 bonds. Okay, it must. It has 4 valence electrons. It needs to have 4 bonds. In this picture here, we only have 2, so that doesn't work. All right. We also know because oxygen has 6 valence electrons, each oxygen needs to have 2 bonds. And so here, if you look at this, each oxygen only has 1 bond. So we could tell that there's something wrong that's going on here. All right. Now, this is an unstable structure. So what can happen at times is that now atoms could actually form multiple bonds within one another. And so in this case, what we'll do is that then we're going to share another set of electrons from one another. So like, for example, now I'm going to make these two into a bond. So between the oxygen and this carbon, they're going to share those 2 electrons, and then same thing with here. All right, and so I'm going to kind of redraw this and just kind of reorganize it so that way it looks better. All right, but basically what you're going to have is that you're going to have oxygen, all right, and the carbon here, and what they're going to do now, they're going to share 2 sets of electrons. Okay, this right here is what we call a double bond. All right, a double bond consists of 4 shared electrons. Okay, and this must be the case with in this molecule, because you only have 1 carbon attached to two oxygens. So now let's kind of look at what's kind of going on here and determine, if I'm gonna just kind of erase all this and determine if we have the correct number of electrons. All right, and so now if we look at carbon here, remember carbon has 4 valence electrons. Now in this case, carbon also has 4 bonds. All right, we got 1, 2, 3, 4. Cool. Oxygen, let's look at each of our oxygens here. All right, if you look at oxygen has 6 valence electrons, and because it has 6 valence electrons, it must have 2 bonds. And does each oxygen have 2 bonds? Yes, it does, right? We got 1, 2 for this oxygen and 1, 2 for this oxygen. And you could count up how many valence each of the atoms have. So for this oxygen here, we got 1, 2, 3, 4, 5, 6, 7, 8. So this oxygen has access to 8 electrons. This oxygen as well, right? 2, 4, 2, 4. Each line is 2 electrons, right? 2, 4. 5, 6, 7, 8. So this oxygen to the right has access to 8 electrons. What about the carbon in the center? Well, this carbon has 1, 2, 3, 4, 5, 6, 7, 8. So it itself also have access to 8 electrons. And so this is the correct stable structure of carbon dioxide. Okay, let's look at another example so you can see where I'm coming from here. So let's look at nitrogen. Right, we know that nitrogen has 5 valence electrons. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And so if there was to make a single bond, right, between the two. So we're saying that these two electrons here, these are the two electrons that these nitrogens are going to share. Then you can see there's going to be something wrong with this, because then essentially what's happening is, I'm going to draw this out. All right, what we do know is nitrogen has 5 valence electrons. If it has 5 valence electrons, it needs to create 3 bonds, right? What we see here for each nitrogen, there's only one bond, and that's just that one bond in the center. All right, so here we have ourselves an unstable molecule. All right, we got to reach stability. This is not going to happen. So what do we do here? Okay, well, you're going to have to set up as many bonds as you can until you see that each nitrogen has 3 bonds. And so what we can do is, in this case, set up a bond between this electron and that electron, and set up another set between this electron and that electron. All right, and so what we're going to have is something that looks essentially like this, where you have your 2 nitrogens, all right, and what you'll see, here's our original bond, and then these are the 2 new ones that I talked about. Okay, so now we have nitrogen with 3 bonds. Each nitrogen has 3 bonds, and if you were to count up how many electrons do they have, each one will actually fulfill its octet, right? So this nitrogen on the left, you have 1, 2, 3, 4, 5, 6, 7, 8. So here we have 8 valence electrons. What about the one on the right? Well, we have 1, 2, 3, 4, 5, 6, 7, 8. So this side also has 8 valence electrons. So this is the correct way of drawing the nitrogen atom. All right, and so to quickly summarize, all right, so we have single bonds, and that's the one we've been talking about, at least from the last video, where we have 2 shared electrons. All right, now then you also have double bonds. All right, double bonds consist of 2 lines. All right, then in this case you have 4 shared, let's move this over, shared electrons. And then lastly, you will have what we call triple bonds. Now triple bonds consist of 3 lines between 2 nuclei. All right, and you have 6 shared electrons between those 2 nuclei. So let's look at this molecule here, right? And so we're not going to add any more atoms, all right? And so you want to make sure that in this molecule that you have the correct number of covalent bonds between each of the atoms, okay? And so let's kind of take a look at this. And I'm going to look at the hydrogens, all right? So we know that hydrogen has 1 valence electron. So in this case, it should have 1 bond. Okay, and so let's look at all our hydrogens here. So this hydrogen here has its 1 bond. This one has its 1 bond. This one has its 1 bond. This one has its 1 bond. So all our hydrogens all have its 1 bond. So all our hydrogens are good. Okay. Now carbon has 4 valence electrons, and we know that it must have 4 bonds. All right. So if we start on the one on the right, let's look at what we have here. All right. So let's consider this carbon here. Yes, this carbon here has 4 bonds, so this carbon's cool. Let's look at here. Well, this carbon has 4 bonds as well, have access to 4 sets of electrons. Okay, we're cool. Now let's turn our attention to this chlorine here. This carbon here. This carbon only has access to 3. Okay, bonds. This carbon also only have access to 3 carbons. So the question is what do we do from here to help to make sure that these carbons all have access to 4 bonds or have access to 8 electrons? Well, in this case, what I would do is that I would create a double bond here. By creating this double bond here, we'll see that this carbon now has access to 2, 4, 6, 8 electrons, or it has 4 bonds. And then this carbon here, same thing, 2, 4, 6, 8. So it has access to 8 electrons, or in a sense, we could say that carbon has 4 bonds. Now we also have something that are called coordinate covalent bonds. Now, coordinate covalent bonds are basically covalent bonds that are formed when both electrons are donated by the same electron or same atom. All right, so what do I mean by that? So like, for example, let's say we have BF3. Okay. So here's BF3. And now remember we talked about boron is an exception. Boron really only needs to have 3 bonds, all right? And it's completely stable. But time to time, what you can do, or what can happen really, is that you could have what we have BF4. Now this is a legit molecule, all right? It's really more of a polyatomic than anything else. But then you have this 4th compound here, or 4th atom here, that's joined in. Now, if you actually kind of pay attention to how many electrons here, then you see that this shared set of electron has actually came from directly from the fluorine itself. All right, and so we have this, and this compound actually overall has a negative charge. All right, or this molecule has a negative charge. So this is what basically a coordinate covalent compound. That sometimes you may have some atoms that may have to have more bonds than we typically assume. So this is somewhat of an exception, right? And so here's another exception. If you think about the polyatomic ammonium, ammonium is the same idea, NH4 plus, right? Where you have this nitrogen that is actually bonded to 4 hydrogens. Okay, now where's the coordinate compound here? Well, if you recall, without this 4th H, right? This right here is NH3. The name of this is conveniently called ammonia. All right, now nitrogen has these 2 lone pairs, or has this set of a lone pair electrons. And then what you're going to have, you have this hydrogen ion that has no electron. All right, and so these electrons are going to be shared between this hydrogen and the nitrogen. Now, both the electrons are coming from the nitrogen, so that's why it's considered to be a coordinate covalent bond. All right, and so when this happens, then you have N, and you have 4 H's. All right, and it also turns out that this molecule is also a polyatomic ion. It's an ion, so it has a +1 charge.